Welcome to your ultimate pit stop, Piston Pundit. They say EVs have ignited a revolution in the automotive world, but they forgot to mention they're also igniting actual flames. That's right. EVs are catching fire at charging stations, parking lots, and even on assembly lines, posing significant safety challenges. EV makers are stunned by the sheer number of incidents, and it seems like nobody is doing anything about it. Let's delve into why these fiery incidents are causing such a stir. Number 7. EV fire incidents. Rarity or reality. While initial data suggests that EV fires might not be as concerning as they appear, a deeper analysis reveals a different story. Studies indicate that the incidence of EV fires is proportionally lower compared to internal combustion cars. For instance, an Australian study found that 0.1% of combustion cars caught fire between 2010 and 2020, compared to just 0.0012% of EVs. Similarly, the Swedish Contingencies Agency reported 68 fires per 100,000 combustion vehicles versus 3.8 per 100,000 EVs. However, EV fires are significantly harder to manage due to thermal runaway, a self-sustaining chemical reaction. EV fires also have a higher risk of reignition, with 13% of cases reigniting, sometimes even months later. Additionally, the difficulty in accessing the battery pack and the enormous amount of water required to extinguish these fires, as seen in a Tennessee Nissan incident needing over 45,000 gallons of water, further complicates the situation. Number 6. The Hackensack fire incident. Over the past decade, electric cars have seen significant advancements in performance, range, charging speed, and overall usability. However, a major safety concern remains: EVs catching fire. The recent incident in Hackensack serves as a stark reminder of these challenges. In March, a smoke detector was activated in a Hackensack parking garage early in the morning. Firefighters arrived to find a parked electric Audi Q5 on fire. Unlike typical fires, extinguishing an EV blaze is a complex task. It took over 7 hours and thousands of gallons of water to cool the battery and prevent reignition. The intense heat generated by burning batteries, which can reach up to 5,000 degrees Fahrenheit, equivalent to 2,800 degrees Celsius, far exceeds the 1,500 degrees Fahrenheit, equivalent to 800 degrees Celsius, of combustion car fires. This extreme temperature and the battery's location under the cabin make it difficult for firefighters to access and cool the source. Despite their efforts, EVs often burn to the ground, and the best that can be achieved is to protect the surrounding area. Number 5. China, the epicenter of EV fires. China leads the electric revolution with the most EVs on the road and the most developed charging infrastructure. Consequently, it also has the highest frequency of EV fire incidents. These fires occur so often that keeping track is difficult. Official sources reported over 3,000 fire incidents in 2021 alone. Since then, Chinese officials have stopped releasing such data, likely due to the significant increase in EV numbers over the past 3 years. EVs now make up about a third of China's new car market, with over 8.4 million electric cars produced annually. Given this surge, it's reasonable to assume that fire incidents have become more frequent, explaining the lack of updated official data. Before we delve deeper, do us a favor and smash that like and subscribe button. This helps us reach more auto enthusiasts just like you. Now let's shift gears and steer towards our next point. Number 4. Global EV fire incidents. EVs continue to catch fire unexpectedly, damaging reputations and deterring new adopters. These incidents highlight the urgent need for more research and investment to address electric vehicle fire challenges. Despite advancements, EV makers struggle to manage fire risks. Last December, a battery fire at GM's factory caused $1 million in damages and required nearly 100 firefighters. Fires also occur at charging stations, as seen recently in Oslo, where an electric bus ignited, causing significant damage. Densely populated areas face major challenges, like the March incident in Colorado, where an EV fire escalated into a full-scale garage blaze. Similarly, in Shanghai, multiple EVs caught fire in a residential garage, causing substantial structural damage. Number 3. Spontaneous combustion concerns. Beyond thermal runaway, the spontaneous ignition of EVs remains a major concern. Unlike internal combustion cars, EVs can catch fire even when parked and unplugged due to design flaws that manufacturers have yet to fully resolve. The tragic fire on a cargo ship near the Dutch coast, carrying 3,000 vehicles including 500 EVs, resulted in the death of a crew member and significant environmental damage. In many regions, EVs are banned from ferries, and owners are advised to park them outdoors, away from other vehicles. This cautious approach stems from the recurring issue of spontaneous EV fires, which continue to pose significant safety risks. Number 2. Insurance implications and costs of EV fires. The frequency of EV fires significantly impacts insurance costs. EV insurance premiums are typically higher than those for internal combustion vehicles, driven by the high costs of battery replacement and repair after a fire. The extensive damage often leads to total vehicle loss, as seen in a Tennessee incident involving a Nissan Leaf, where the car was unsalvageable. Environmental cleanup costs add another layer of expense, as chemicals from burning lithium-ion batteries can contaminate the area, requiring specialized efforts. Insurers are adjusting their risk models to account for these challenges, and vehicle owners face potential increases in premiums and deductibles. Addressing these insurance challenges is crucial as the EV market grows, ensuring both insurers and vehicle owners are protected. Number 1. Future technologies to mitigate EV fire risks. As the electric vehicle market grows, innovative solutions to mitigate EV fire risks are vital. Solid-state batteries featuring solid electrolytes instead of flammable liquid ones are a promising development by companies like Toyota and QuantumScape. These batteries reduce thermal runaway risks, enhancing overall safety. Advanced fire suppression systems integrated into battery packs can detect thermal runaway signs early and deploy fire-retardant materials to contain and extinguish fires. The U.S. Army's experiments with fire-resistant materials for lithium-ion batteries could be adapted for civilian EVs. Improvements in battery management systems, BMS, are also crucial. Modern BMS technology monitors battery health and performance, using sensors and algorithms to detect anomalies and take preventive actions to avoid overheating and fires. Public awareness and education about proper EV handling, charging, and maintenance are essential to minimize fire risks, ensuring a safer future for electric vehicles. Thank you for watching. If you found this video informative, make sure to subscribe to Piston Pundit so you don't miss our next video. See you next time.